Okay, today we will discuss the properties of pure substance. Okay, define muna natin kung ano yung pure substance. Pure substance is a substance that has fixed chemical composition. An example na fixed ang chemical composition na substance ay water, which contains dihydrogen monoxide, nitrogen or N2, helium, and carbon dioxide. Okay, meron din tayong mga mixture of various chemical elements that is considered as pure substance. As long as yung mixture niya or homogeneous or yung concentration ng mga chemicals ay pare-pareho. Example is air, di ba? Example is the air. The air consists of 78% nitrogen, 21% oxygen, and small amount of other gases such as carbon dioxide, neon, and hydrogen. Okay, ito yung illustration niya, the illustration of matter. Matter, meron tayong tinatawag na pure substance and mixture. Pure substance consists of elements and compounds. Pag element, single element lang siya. Pag compound, consists of bonded molecules. Ang mixture naman, meron tayong tinatawag na homogeneous and heterogeneous mixture. Homogeneous mixture consists of elements or compounds in uniform concentration. While the heterogeneous mixture, it consists of different compounds which has different phases. Makita natin dito yung sa arrow, yung kulay pula. Yung may kulay pulang element is in gaseous form, while the one with green element is in liquid form. Ito lang yung when two pure substance are mixed together, they are called mixture. Mixture, di ba sinabi natin kanina that mixture can be also pure substance as long as the composition is homogeneous. Another thing is, tinatawag din natin pure substance ang isang mixture ng isang chemical with different phases. For example, a mixture of ice and water, they are both dihydrogen monoxide, they are considered as pure substance because they have the same chemical composition. Okay, meron tayong three principal phases of pure substance that can be in solid, liquid, or gas. Example natin at room temperature and pressure, copper is solid, mercury is liquid, and nitrogen is gas. Under different conditions, each may appear in a different phase. For example, yung copper at a very high temperature, nagme-melt siya. Mercury, na tumitigas siya or naging solid form at low temperature, while nitrogen can be compressed or liquefied at a high pressure. Ito naman yung characteristic of molecules of solid, liquid, and gaseous phase of sa pure substance. Okay, pag solid, fix yung position ng molecules. Liquid they are moving about each other. They move about each other. While the gas phase, molecules move at the random. Kung makita natin, pinaka-violent yung movement ng gaseous or ng gaseous elements or gaseous pure substance. Natin dito yung solid, they are bonded together, and then yung liquid, they move but they are not bonded together. Intermolecular bonds are strongest in solids and weakest in gases. One reason the molecules in solids are closely packed together. Meron tayong tinatawag na phase change process of pure substances. Diba? Yung tulad ng tubig, diba? It changes in phase. For example, from solid in the form of ice, turn into liquid, or into gaseous state in the form of water vapor. Ito yung example natin. Meron tayong dito isang container kung saan nag-heat tayo. And yan, ang initial state niya, which is the state 1, the liquid is not about to vaporize. Ang pressure ng tubig is 1 atmosphere at 20 degrees Celsius. Siyempre, nag-add tayo ng heat, it will change into another state. Diba? Pag nag-add tayo ng heat, mag-increase yung temperature niya to the point of 100 degrees Celsius. Pagka 100 degrees Celsius na, it is about to vaporize or tinatawag nating saturated liquid. And then, ano mangyayari kapag continuous pa rin yung heating natin at continuous pa rin na at 100 degrees Celsius at constant temperature, continuous pa rin na nag-heat? magkakaroon tayo ng mixture ng vapor and liquid. Yan yung tinatawag nating state 3, saturated liquid-vapor mixture. Liquid and vapor phases coexist. And then, over time of heating, ang nangyayari dyan, mag-evaporate lahat ng tubig, kaya tinatawag natin siyang saturated vapor or state 4, a vapor that is about to condense. At 100 degrees Celsius, all water turn into vapor state. It is about to condense kasi pag bumaba lang ng konti yung temperature niya, for example, bumaba ng 99 degrees Celsius, magko-condense na yung tubig. And then, at continuous heating, ang mangyayari dyan, tataas pa yung temperature. Pag tumaas pa yung temperature at continuous heating, tinatawag nating superheated vapor or state 5. The vapor is not about to condense. Dahil nga mataas ang temperature niya, it is impossible for it to condense at a constant pressure. Okay, ito at constant pressure, ito yung relationship ng temperature and specific volume. Makikita natin yung vertical line is the temperature and the horizontal line is the specific volume. At constant pressure, ito yung state at 20 degrees Celsius. It is cold compressed liquid. And then, pagdating dito sa state 2, it is about to vaporize. The water is about to vaporize at 1 atmosphere at 100 degrees Celsius. And then, mag-start na magkaroon ng vaporization, magkakaroon ng saturated mixture or liquid vapor state kung saan i-convert natin yung liquid into gas. As we converted, habang tumataas yung ratio ng vapor, tumataas din yung specific volume. Pagdating dito sa state 4, ito na yung specific volume ng vapor gas. Sa state 4, ito na yung specific volume ng vapor gas. And then, when we add temperature at a superheated state, tataas pa yung kanyang specific volume. Ang temperature-specific volume relationship is increasing. It has direct relationship. Meron tayo tinatawag itong statement. Statement, water boils at 100 degrees Celsius is incorrect. Ibig sabihin, hindi lahat ng condition at 100 degrees Celsius ay magbo-boil ang water. Hindi lahat ng boiling point ng water at different pressure is 100 degrees Celsius. 100 degrees Celsius boiling point is only applicable at 1 atmospheric pressure. Because pagka mas mababa yung pressure natin, mas mababa ang boiling point. Pag mas mataas ang pressure ng system natin, mas mataas din ang boiling point. Okay, ito yung terminology natin. Saturation temperature. Saturation temperature, the temperature at which pure substance change in phase. Okay, and the pressure at which pure substance changes phase is called saturation pressure. Ito naman yung pressure kung saan pure substance could change its phase. Ito yung example. At a pressure of 101.325 kilopascal, the saturation temperature is 99.97 degrees Celsius. Ibig sabihin, ang exact value or ang exact temperature natin para mag-evaporate yung water or mag-start na ma-convert into vapor is 99.97 degrees Celsius at 101.325 kilopascal. At a temperature of 99.97 degrees Celsius, the saturation pressure is 101.325 kilopascal. Ito yung illustration nito. For example, at negative 10 degrees Celsius, ang saturated pressure niya para mag-evaporate is 0.26 kilopascal. At negative 5 degrees Celsius, 0.40. At 0 degrees Celsius, kailangan niya ng 0.61 kilopascal ng pressure. And then, ito yung atmospheric condition at 100 degrees Celsius, kailangan niya ng 101.4 kilopascal na saturated pressure. And then, as temperature increases, the saturation pressure also increases. Ibig sabihin, ang Ang saturation pressure ng water at 300 degrees Celsius is 8,588 kilopascal. Ayan, makikita natin yung graph. As the saturation temperature increases, the saturation pressure increases. Meron tayong tinatawag na latent heat of fusion. It is the amount of energy absorbed during melting, which is equivalent to 333.7 kilojoules per kilogram. Ibig sabihin nito, at 0 degrees Celsius, kailangan ng 337 kilojoules per kilogram para mag-melt ang ice. At the same time, kailangan niya na ma-reject yung 337 kilojoules per kilogram yung water at 0 degrees Celsius para ma-solidify siya, maging latent heat of vaporization. It is the amount of energy required to vaporize or release during condensation. Okay, at latent heat of vaporization is 2,257 kilojoules per kilogram at 1 atmospheric pressure. Kailangan natin ng, for example, ang 1 kilogram of water at 100 degrees Celsius, kailangan niyang additional 2,257 kilojoules per kilogram for it to completely vaporize. Okay, ito yung property diagram na meron tayo. TV diagram at constant pressure, PV diagram at constant temperature, PT diagram at constant specific volume. Yan natin. I-illustrate natin yung relationship ng bawat isa. Okay, TV diagram or temperature specific volume diagram. At a given pressure, ito yung diagram kanina. Kung saan ito yung itong nasa left side is the compressed liquid. And then at this point, may certain point siya na darating kung saan mag-start na siyang mag-vaporize. Itong line na to, itong horizontal line is the saturated liquid vapor mixture. And then at these points ay pure ano na siya, pure vapor na siya or saturated vapor state na siya. And then superheated na as temperature increases. Meron ito yung tinatawag na critical point. It's the point where the saturated liquid and saturated vapor are identical. Yan yung from this point na biglaan na lang siya magka-transform into vapor. KTV diagram or temperature specific volume diagram at a constant pressure. Kita na dito sa TV diagram, ito yung saturated liquid line and saturated vapor line. Ito yung boundaries na niya kung saan yung left side is compressed liquid and its right side is the superheated vapor. And then yung nasa loob ng arc na yun or ng curve na yan ay tinatawag na saturated liquid vapor region. PV diagram, makikita natin dito sa pressure increases, the specific volume decreases. Katulad din kanina, ito yung right side, it is the compressed liquid region of water. And then itong right side is the superheated vapor region. And then ito nasa loob ng curve, ito ang region kung saan may mixture tayo ng liquid vapor. PT diagram. Okay, yung pressure and temperature at constant specific volume. Kung constant is specific volume natin, from this point, meron tayong tinatawag na sublimation from solid to. Ito yung line natin ito yung sublimation line natin at this point. Nagsasublime yung water from ice to vapor. Ito yung pressure temperature diagram at a constant specific volume. Ano natin tinatawag ditong sublimation line? Kung yung values ng temperature and pressure lies in this line, Ibig sabihin, yung tubig natin transform from ice to vapor. Then, ito yung melting line natin. Kung saan at these points ay yung temperature, at this point at a given temperature and pressure, nagme-melt yung water natin. And then, at this point naman, or on this line, ito yung exact values kung saan. Ito yung, dito naglalay yung values ng pressure and temperature natin at vaporization state. And then, kapag wala siya sa line, for example, itong area to, nandito yung area to, nandito sa area to yung value natin ng pressure and temperature, nasa solid state siya, nasa vapor na state naman yung water natin at this area, and then nasa liquid state yung water natin at this area. Meron tayong tinatawag na tripole point. Ang tripole point ay ito yung point na kung saan nag-exist yung solid, liquid, and vapor. Ito namang critical point, ito ay point kung saan identical naman or nag-exist yung liquid and vapor. Identical liquid and vapor state. Ito naman yung 3D diagram. Pinakita lang yung pressure, specific volume temperature diagram. Ayan, ito yung vertical line is pressure, and then ito yung volume and temperature. Yan, hindi naman natin siya masyadong i-discuss, pero at a given point, kapag naglay dito sa point na to, yung pressure, temperature, specific volume natin, nasa solid state siya. Pag naman banda rito is liquid. Ayan, pag dito solid vapor, liquid vapor, and triple line. Ito yung triple point natin kanina. Kung it's triple line kasi meron tayong different specific volume. Hindi constant yung specific volume niya. Tinatawag tayong enthalpy. Ito yung total heat content of a system. It consists of energy plus the product of pressure and volume. Okay, for the enthalpy, H is equals to U plus PB, where U is the internal energy plus P, pressure times V, or the volume. Ang unit natin ay kilojoule. Ang unit mass basis natin, pag-compute ng enthalpy per unit mass, is equals to internal energy per unit mass, plus pressure times specific volume. Kakailanganin nyo yung water property table or yung tinatawag na steam table. I have also uploaded it on Google Classroom. Meron tayong tinatawag na specific volume of saturated liquid, specific volume of saturated vapor, and VFG is the difference between VG and VF. VFG is equals to VG minus VF. Okay, ito yung tinatawag nating water property table or steam table. Mas maganda sana kung i-print nyo to para mas madali kayong makapag-compute. Okay, meron tayong tinatawag na temperature at this given temperature, ito yung equivalent saturated pressure natin. For example, dito tayo sa 20 degrees Celsius. Ang 20 degrees Celsius, kailangan niya ng 2.3392 kilopascal for it to vaporize or for it to change phase. And then yung volume natin ng saturated liquid ay ito. Itong naka-highlight na to, 0.001002 cubic meter per kilogram. Pero kung naka-vapor state na siya, ang specific volume niya is 57.762. Then meron tayong tinatawag na internal energy. Ito yung value niya, equivalent internal energy, 83.90913 at liquid state, saturated liquid state. Saturated vapor state is 2,402.3. Ano naman itong 2,318.4? Simply the difference of UG and UF. UG minus UF, ito yung value niya, UFG. Ganun din sa enthalpy. Okay, ang enthalpy at liquid state or saturated liquid state ay 83.915 at 20 degrees Celsius. And then saturated vapor is 2,537.4. And then itong 2,453.5 is the difference of Hg and Hf. 2,537.4 minus 83.915 is equals to 2,453.5. Ito naman yung molecular or yung entropy or the molecular randomness of the system. Okay, ang entropy at liquid state is 0.3672 and then at saturated vapor is 855.67. And then yung difference niya is 8.1895. Ang gagamitin lang natin dito or yung pinaka-common na gagamitin natin is yung temperature, saturated pressure, specific volume, enthalpy. Yung internal energy hindi natin masyado magagamit. Pero yung internal energy kasi is no, ang enthalpy kasi ito na-compute na siya. Internal energy is for example, itong HF, U 2000 HF is UF 104.83 plus PV, which is the PV is itong 3.1698 times 0.001003. Okay, itong enthalpy is computed na U plus PV. U plus PV, ito na yon, enthalpy, U plus PV. Na-compute na siya dyan. Okay, meron tayong saturated water temperature table. Ito yung at a given temperature. Ito yung values niya. Meron naman tayong saturated temperature na hinahanap at a given pressure. Ito naman yung table A5. Saturated water pressure table. For example, at 100 kilopascal, which is nearly 2 atmospheric pressure, ang saturated temperatures niya is 99.61 degrees Celsius. Then specific volume niya at liquid state ay ito, 0.001043 cubic meter per kilogram. And then yung specific volume niya at vapor state is 1.6941. And then internal energy at liquid state or saturated liquid is 417.40. And vapor state, saturated vapor state is 2,505.6. And then yung difference niya, 2505.6 minus 417.4 is equivalent to 2,088.2. Then yung enthalpy, yan, yung U plus PV. Kinompute lang ng U nito. And then P plus P times specific volume. Ayan, same pa rin. Ito naman ang table A6 ay superheated water. Okay naman, itong table A6 natin is the superheated water. Ito yung saturated condition niya at pressure of 0.01 megapascal, 45.81 degrees Celsius yung saturated temperature niya. Ito yung specific volume niya, enthalpy, internal energy, enthalpy, and entropy. And then, at the higher state or at higher temperature, ito yung equivalent values niya. Then, meron tayong 0.05, saturated temperature niya is 81.32. Then, 0.1, meron tayong 0.2, 0.3, 0.4, 0.5, 0.6, 0.8 hanggang 60 megapascal, meron tayong hanggang 60 megapascal. Yun yung data na meron tayo at superheated vapor state. Then ito yung compressed liquid water. Makita natin dito masyadong baba yung mga differences niya. Nag-start tayo at 5 megapascal ang at 0 at 5 megapascal at 0 degrees Celsius. Ito yung values ng specific volume natin. Ito yung value ng internal energy, enthalpy, and entropy. Ayan. Okay, let's take a look to this example. Pressure of saturated liquid in tank. A region tank contains 50 kg of saturated liquid water at 90 degrees Celsius. Determine the pressure in the tank and the volume of the tank. Okay, we have saturated liquid water in a tank with 50 kg. So, hinahanap natin pressure and the volume of the tank. Yan yung given natin and yung hinahanap natin. So, paano yung gagawin natin dyan? Let's refer to the steam table given yung temperature, nahanap natin yung saturated pressure and volume. Para natin makuha yung saturated pressure, yun yung ipa-plot natin or hahanapin natin sa table. While the volume of the tank, we look for the specific volume of saturated liquid and then i-multiply natin siya sa mass ng liquid water. Okay, its search is 90 degrees Celsius. Okay, hanap tayo sa steam table. Ang given natin ay temperature. So, dito tayo maghahanap sa table A4. Ay nahanap natin 90 degrees Celsius. Ito, at 90 degrees Celsius, ang saturated pressure niya ay 70.183. So, yung pressure in the tank is 70.183, while the specific volume ay 0.001036. So, yun yung given natin. Okay. Ito yung pinlat natin kanina, yung pressure at 90 degrees Celsius ay 70.183. And then, yung specific volume at 90 degrees Celsius, since liquid, yun yung 0.001036 cubic meter per kilogram. And then, multiply natin siya sa mass, na-cancel yung kilogram, so we got 0.0518 cubic meter. Or kung i-convert natin niya sa liters is 51.8 liters. Ito yung graph natin. So, saturated liquid natin. So, papasok yung point niya sa saturated liquid line natin. At 90 degrees Celsius, sinanap natin yung specific volume. Nakuha natin ng 0.036. And then, yung pressure niya is 70.183 kilopascal. Next problem. Okay, temperature of saturated vapor in a cylinder. A piston cylinder device contains 2 cubic feet of saturated water vapor at 350 kilopascal pressure. Determine the temperature and the mass vapor inside the cylinder. Ito naman, ang given natin ay 350 kilopascal ng cylinder. Hinahanap natin ay saturated temperature niya and the mass inside the cylinder. Paano natin hanapin? Hanapin natin siya sa graph. And then, gamit yung specific volume naman natin, makukuha natin yung mass ng vapor. Okay. Ang nahanap natin ay saturated temperature given ang pressure. Ang pressure natin ay 350 kilopascal. So, punta tayo sa table A5. Ito. A5, saturated water pressure table. Hinahanap natin 350 kilopascal pressure. Itong hinalight ko. 350 kilopascal pressure. Ang saturated temperature niya ay 138.86 degrees Celsius. So, ito na yung sagot natin. 138.86 degrees Celsius. And then, given yung saturated vapor, kopyahin natin to, makukuha natin ang mass of the vapor inside the cylinder. Ito yung natin kanina, hinanap natin sa table kanina. Ang saturated temperature at 350 kilopascal is 138.86 degrees Celsius. And then ang specific volume of saturated vapor is 0.52422 cubic meter per kilogram. So, paano natin makuha yung mass? Para makuha natin ang mass, kailangan natin ng volume all over the specific volume. Kaya mapapansin natin, unit derivation lang papalabas natin yung kilogram. So, yung 2 cubic feet, convert natin into cubic meter. Pag dinirect na kinalculate natin dyan, we will get 0.109 kilogram. Okay, yan yung graph niya. Pressure specific volume diagram. Ang point natin or ang saturated vapor natin ay papasok sa saturated vapor line. Ito yung saturated vapor line. Another problem, we're looking for volume and energy change during evaporation. A mass of 200 grams of saturated liquid is completely vaporized at a constant pressure of 100 kilopascal. Determine the volume change and the amount of energy transferred to the water. Okay, initially, meron tayong 200 grams of liquid water and it was vaporized at a pressure of 100 kilopascal. Hinahanap natin yung volume change and amount of energy transferred to the water. 200 grams, 100 kilopascal, hinahanap natin yung volume change or delta V, and amount of energy transferred to the water or the enthalpy. It's hindi siya internal energy. Pag sinabi mo kasing internal energy, hindi involve yung change in pressure and volume. Kaya H yung hinahanap natin, total amount of energy in the system. Ito yung magiging graph natin. From state 1, 100 kilopascal saturated liquid, it will be changed into state 2 at 100 kilopascal, then at a constant pressure at saturated vapor state. So, ang hinahanap natin is volume change. Sa graph natin, ito, yung change in volume from Vg minus Vf times the mass. And then, the amount of energy, which is the enthalpy, or the change in enthalpy. So, again, balik tayo sa graph. Sa graph, I mean sa table, sa steam table. Okay, given I, pressure, so gagamitin natin I, saturated water pressure table, or A5. Okay, pressure is 100 kilopascal. 100 kilopascal. Ang hinahanap natin ay change in volume. So, kailangan natin ng saturated vapor, specific volume ng saturated vapor, and specific volume of saturated liquid. Para makuha natin yung change in volume. Ito. And then another na kukunin natin ay yung enthalpy, or dahil kailangan natin ng enthalpy, nahanap natin yung enthalpy. Ito yung enthalpy niya at liquid state, saturated liquid state, and enthalpy at saturated vapor state. And then ito yung HFG is the difference of HG minus, ito yung HG minus HF. HG minus HF. So, yan natin yung mga given. Ilagay natin yung mga nakuha natin values. Okay, ang formula natin para makuha natin yung change in saturated, change in volume is, kunin muna natin yung VFG or yung change in specific volume. Ito yung VG, ito yung kanina kinuha natin, at saka yung VF from the table. We got 1.6931 cubic meter per kilogram ang change in volume, or specific volume rather. And then kung to get yung mismong change in volume, yung mass times change in mass times VFG or change in specific volume, 0.2 kilogram times 1.6931 cubic meter per kilogram is equals to 0.3386 cubic meter. So, ibig sabihin, from the liquid state, nag-increase siya ng 0.03386 cubic meter in volume. And then, yung enthalpy, we get the, ganun din. Kung kukunin natin yung HG minus HF, yun yung HFG. Pero, pag given na naman sa table natin yung difference nila, yung HFG, so we can directly substitute the values that we get from the table. Itong 0.2257, 0.5 we get from the table. So 0.2 times 0.2257 or 2,550, 0.2 kilogram times 2,257.5 kilojoules per kilogram, we will get 451 kilojoules. Yan yung change in enthalpy natin. Meron tayong tinatawag na saturated liquid vapor mixture, kung saan yung system natin may mixture na ng liquid and vapor. Okay, sa saturated liquid and saturated vapor, madaling mag-compute ng specific volume or ng volume ng substance. Pero sa saturated liquid vapor, kailangan nating malaman yung ratio ng liquid and ratio ng vapor. During vaporization process, in the mixture, there are part of liquid and part of vapor. Paano malalaman natin yung proportion ng mixture, kailangan natin ng property na tinatawag nating quality. Wherein the quality is the mass of vapor over the total mass of the mixture. Yung total mass ng mixture natin is the mass of the liquid plus the mass of the vapor. Ito yung condition natin. Kapag saturated liquid yung system natin or yung mixture natin, ang quality is equals to 0. Dahil nga liquid lahat, there is no vapor. Kung 0 yung vapor, 0 over total mass is equals to 0. And then, kung lahat naman ng fluid na mixture na system is in saturated vapor state, the quality is equivalent to 1 or 100%. Because the mass of the vapor is equals to total mass, so we get X is equals to 1. So, pagkuha natin ng quality in relation to specific volume, we have this formula. The average specific volume is equivalent to specific volume of saturated liquid plus the quality times the difference of saturated vapor and saturated liquid, yung specific volume. And then, pag niride natin yung quality, X is equals to average specific volume minus specific volume saturated liquid 1 over the difference of specific volume or VFG. Sa pagkuha natin ng internal energy and enthalpy, we have the same formula. Or U average or average internal energy is equals to UF minus X times UFG, while the H average or the average enthalpy is equal to HF minus X HFG. Okay, meron tayong sample or problem. A rigid tank contains 10 kilograms of water at 90 degrees Celsius. 8 kilograms of water is in liquid form and the rest is in the vapor form. Determine the pressure of the tank and the volume of the tank. We have the total mass of 10 kilogram. Ang temperature natin ay 90 degrees Celsius. And then 8 kilogram is water. So, kung 8 kg yung water natin, ang vapor natin is equivalent to 2 kilograms. Hinahanap natin yung pressure in the tank and volume in the tank. Okay, yan yung given natin. Okay, yan. Kung gagamit tayo ng steam table, ang hahanapin natin ay pressure in the tank. Yung equivalent saturated pressure niya, yun ay yung pressure in the tank. And then the volume of the tank, para makuha natin yung volume in the tank is kailangan natin muna malaman yung values ng specific volume ng saturated vapor and saturated liquid. Makikita natin yung condition dito, yung condition ng mixture wherein the specific volume of saturated liquid is less than the average specific volume and the average specific volume is less than the specific volume of saturated vapor. So again, we will look at the steam table to get the values of pressure and specific volumes. Given yung temperature, so ang gagamitin natin ay saturated water temperature table. Ang saturated water, ito, table A4. And then, ang temperature natin ay 90 degrees Celsius. Ito yun, 90 degrees Celsius. Ano yung saturated pressure at 90 degrees Celsius? We got 70.183 kilopascal. And then, kunin natin yung specific volume ng vapor and specific volume of liquid. Saturated vapor and saturated liquid. So, we get it. Ilagay natin sa given natin or sa assumptions natin. Kaya saturated pressure at 90 degrees Celsius, we get 70.183 kilopascal from table. And then, ang nakuha natin naman sa table natin at 90 degrees Celsius, ang saturated saturated liquid natin, specific volume niya ito. Ang specific volume naman ng saturated vapor ay 2.3593 cubic meter per kilogram. Then, makukuha natin yung total volume niya. Ano yung formula ng total volume natin is mass times specific volume. Okay, yung volume ng liquid and volume ng gas. We have sa volume ng saturated liquid, we have 8 kilograms times 0.00136 cubic meter per kilogram plus the volume of saturated vapor, we have 2 kilogram times 2.3593 cubic meter per kilogram, or equivalent to 4.73 cubic meter. Okay, another example, ito naman ay refrigerant. Okay, sa refrigerant naman, meron din tayong mga steam table or yung yung katulad equivalent rin ng water property table, pero hindi ko na isinama. Nasa appendix din siya ni Sengel, libro ni Sengel. Pero binigay ko na yung values kasi mag-focus tayo sa water or sa steam table. Okay, 80 liters vessel contains 4 kg of refrigerant 134A at a pressure of 160 kilopascal. Determine the quality, the enthalpy, and the volume occupied by the vapor phase. Okay, assumption natin, ayan na yung kinuha natin sa table. Ito yung pag pinlat natin siya. Yan yung values na makukuha natin. Okay, first is kinuha natin yung specific volume. Hanap natin yung specific volume. Given naman yung volume ng system all over the mass, we get the average specific volume of 0.02 cubic meter per kilogram. Then at 260 kilopascal, kinuha to sa table ng R134A, we get VF is equals to 0.007437 cubic meter per kilogram at 160 kilopascal, and VG is equivalent to 0.12348 cubic meter per kilogram. Ang condition natin ay VF is less than VG. Ang quality natin is V minus VF all over VFG. Ito yung formula natin kanina. Pagkuha ng quality. And then we will get direct substitution. We will get 0.157, which is unitless. Kasi parehas itong cubic meter per kilogram. Hindi ko na-indicate, pero cubic meter per kilogram, lahat ng unit na naka-cancel. Kaya unitless yung quality. Okay, sa pagkuha natin ng enthalpy ng refrigerant, we have H is equals to HF plus HFG. Galing siya sa table, the direct substitute natin, 31.21 plus 0.157 equality times 209.9 is equivalent to 64.2 kilojoules per kilogram. The mass of the volume of the vapor, first is we will get the mass of the vapor, wherein the mass of the vapor is quality times the total mass, 0.157 times 0.4, we get 0.628 kilogram. And then the the total volume niya is the mass times the specific volume of the vapor. Substitute natin yung values niya. We get 0.0775 cubic meter or 77.5 liter. So the rest is 2.5, which is the liquid R134A. Meron tayong tinatawag na superheated vapor. Superheated vapor, ito yung water vapor that is not about to condense. Dahil mataas yung temperature nila above the saturated temperature and above the saturated temperature, they will not vaporize easily. Okay, yung saturated vapor ay matatagpuan lagi sa left side ng graph natin. Okay, pressure and temperature are no longer dependent properties. They are not dependent with each other. Pero, meron silang properties na makukuha sa table. Yung table A7, I think table A7, yun yung superheated vapor. Ang ano ba yung characteristic ng superheated vapor? Mas mababa ang pressure at a given saturation. Mas mababa ang pressure niya, saturation pressure at given temperature. Higher temperature niya compared to saturated temperature. Higher din ang specific volume. Siyempre, mas mataas ang temperature, mas nag-expand yung vapor, kaya mas mataas yung specific volume niya. Same with internal energy. Mataas din ang internal energy niya and enthalpy. Okay, determine the internal energy of water. 140 kilopascal and 200 degrees Celsius. Ang hinahanap natin ay internal energy at 1,400 kilopascal and 200 degrees Celsius. Okay, paano na natin gagawin? Para malaman natin siya kung superheated vapor siya, kailangan muna natin siyang tingnan sa saturated water pressure table. So, tingin tayo 1,400 kilopascal. Yung given natin ay 1,400 kilopascal or 1.4 megapascal yung equivalent niya. Saturated water pressure table, since pressure yung given. Pwede naman din sa pwede naman sa temperature. At 1.4 or 1,400 kilopascal, ito, makita natin dito. Ano yung saturated temperature natin? 195.04. Pero yung given natin is 1,400 and 200 degrees Celsius. So, ibig sabihin, mas mataas yung temperature niya sa saturated temperature, so the given is superheated. Hanapin natin yung internal energy at superheated water. Sabi doon ay 1,400 kilopascal or 1.4 megapascal. Nasaan yung 1.4 megapascal? Ito, 1.4 megapascal kung saan ang saturated temperature niya is 195.04 degrees Celsius. At 200 degrees Celsius, ito yung 200 degrees Celsius natin, naka-highlight. Ang internal energy niya ay 2,602.7 kilojoules per kilogram. Okay, from the table na kinuha natin kanina sa table A5, ito yung saturated pressure table. We get 195.04 degrees Celsius. Since the temperature is greater than the saturated temperature, it is considered as, or it is superheated. Okay, gamit yung table A6 at 1.4 megapascal, we get the internal energy of water at 2,602.7 kilojoules per kilogram. Okay, the temperature of water at state of 0.5 megapascal and H is equivalent to 2,890 kilojoules per kilogram. 0.5 megapascal, temperature at 2,890 kilojoules per kilogram. I-check muna natin kung superheated yung problem natin. Given yung pressure, 0.5 megapascal or 500 kilopascal, Kasi yung 500. 500. Ito, 500 kilopascal or 0.5 megapascal. Ang given dito, ang given kanina ay temperature, ang hinahanap ay temperature of water at a pressure of 0.5 and enthalpy of 2,890 kilojoules per kilogram. So, yung HF ay, kung makikita natin dito, 2,748.1 yung enthalpy of saturated vapor. Mas mataas yung given natin compared sa saturated condition niya. So, ang gagawin natin ay we will consider it as a superheated vapor. Superheated vapor, we have 0.5 megapascal. Ito yung 0.5 megapascal natin. Okay, we have 0.5 megapascal superheated state. Ang value ng enthalpy natin ay 2890. Ang enthalpy natin is in the fourth column, 2890. So, 2890 ay nasa pagitan ng 2855 and 2961. So, equivalent temperature niya is from 200 to 250 degrees Celsius. So, kailangan natin ng interpolation. We'll get 2855.8 as H1 and 2961.0 as H2. And then, ang T1 natin is 200 and 250 ang T2. Okay, at 0.5, yung Hg natin ay 2,748.1. So, ang enthalpy is greater than Hg. So, it is superheated. At superheated, meron tayong 2890. So, it is in between 2855 and 2961. Gamit tayo ng interpolation formula. Ang ginamit ko dito, meron specific formula ng interpolation. Pero nagkaroon ako ng ratio and proportion na lang. So, yung hinahanap natin T minus T1, which is 200, and then T2 minus T1. And then, ito ay H minus H1, and then H2 minus H1. And then, gamit yung calculator nyo, you can use ShipSolve, or you can use algebra, i-transpose nyo itong denominator sa kabila, i-multiply nyo dito, plus 200, makuha natin yung value ng T. T is 216.3 degrees Celsius. Ayan, kailangan nyo aralin yung interpolation techniques. Next is the compressed liquid. Ano ba yung property ng compressed liquid? Ito ay compressed, which is unsaturated or subcooled fluid. It is on the left of the liquid vapor phase boundary. Property niya ay napaka-mild. Yung compression, sabi nga natin, di ba, ang liquid is incompressible. So, ang compression niya is napaka-liit lang. For 100 times, compression niya is, pag kinompress niya ito 100 times, less than 1% lang ang change niya from the saturated liquid condition. Napakababa ng change in properties ng compressed liquid. At ano ba yung property ng compressed liquid? Mas mataas ang pressure niya compared to saturated pressure at given temperature. Mas mababa ang temperature. Lower ang specific volume. Lower internal energy and lower enthalpy. Okay, meron tayong problem. Determine the internal energy of compressed liquid water at 80 degrees Celsius and 5 megapascal using data from the compressed liquid table. Determine the percentage difference from the saturation table. Internal energy from table A7. Hanapin natin yung internal energy, 5 megapascal and 80 degrees Celsius. Table A7 at 5 megapascal at ito, 5 megapascal 5 megapascal Using table A7, ito yung table A7, 5 megapascal at 80 degrees Celsius. Ang hinahanap natin ay internal energy or U. Internal energy, 3,333.82. Okay, we got internal energy at 333.82 kilojoules per kilogram. Ano yung difference siya from saturated table? Para makuha natin yung percentage difference, ano ba yung saturated internal energy niya? Okay, ito ay 334.97 kilojoules per kilogram. Check natin kung 334.97 kilojoules per kilogram. Okay, at 80 degrees Celsius, ano ba internal energy niya? So, 334.97 kilojoules per kilogram. Okay, ito pa, take note, when getting the saturated condition ng water, always look for the temperature, not for the pressure. Kapag compressed liquid. Okay, ito yung percent difference. Paano ba kung tayo ng percentage difference? 334.97 minus 33.82 all over 33.82. Itong 333.82 or 333.82 ay nanggaling sa compressed liquid condition niya, yung kanina sa letter A. And times 100 is equals to 0.34%. Ibig sabihin, 0.34% lang yung difference ng data na compressed liquid sa saturation table natin. Next is gamit tayo ng steam table. Determine the missing properties of the phase description in the following table for water. Okay, for letter A, hanapin natin yung values ng letter A. Kunin natin yung temperature. Okay, I will not show na yung steam table, pero try na hanapin nyo. Okay, ang quality niya ay 0.6. Ibig sabihin, 60% yung 40% yung liquid and 60% yung gas. Pag sinabi natin 0.6 na quality. Kaya ano yung phase description natin yan? Saturated liquid vapor mixture. It is always kapag may mixture ng liquid and vapor, saturated liquid vapor mixture siya. And at 200 kilopascal, sa table A5, I think table A5, sa table A5 na hanapin yan, at 200 kilopascal, ano equivalent temperature niya? Hinanap nyo sa table, we will get 120.21 degrees Celsius. Next is, at 200 kilopascal, ano naman yung internal energy. Internal energy, ano ba yung may formula tayo dun, diba? UF plus X UFG. Yung UF and UFG, kinuha natin sa table. Direct substitution, we will get 1,719.26 kilojoules per kilogram. Next, nakuha natin yung values. Sa letter B naman tayo. Okay, at 125 degrees Celsius, ano yung condition natin? Ano ba yung enthalpy ng 125 degrees Celsius? We get 524.83 and 2,534.3. Ang given internal energy natin ay 1,600. It lies between those value. So, ang natin, ang phase natin is saturated liquid vapor mixture. Nalalaman natin yan na saturated liquid vapor mixture dahil sa condition niya. Saturated liquid vapor mixture. And then, ano naman pwede natin mahanap? Pwede natin hanapin yung pressure at 125 degrees Celsius. Ang pressure niya ay galing yan sa table. Directly, makuha natin ang 232.23 kilopascal. And then, paano natin makukuha yung quality? X is equals to U minus UF all over UFG. Same din yun ang formula na pag-given na specific volume or enthalpy. So, we will get 0.535 yung quality niya, or the ratio of liquid vapor and vapor. The ratio of vapor over the total mass of the fluid. Okay, at 1 megapascal. Ito naman ang next, letter C. At 1 megapascal, ano ba yung internal energy natin? 761.39 to 2,582.8 kilojoules per kilogram. Makita natin, ang value natin ng U ay 2,950, mas mataas sa saturated vapor natin. So, kung mas mataas siya, condition natin ay superheated vapor. U is greater than UG, the phase description is superheated vapor. Ang next na pwede natin hanapin at superheated vapor at 1,000 kilopascal, we could get the temperature. Ayan, pwede naggamit tayo ng interpolation given yung temperature. Okay, paano natin ito nakuha? 395.2. Enthalpy natin kanina, ang pressure natin kanina ay 11 megapascal at superheated state. Ito, 1 megapascal. Hanapin natin yung 1 megapascal or 1,000 kilopascal. Ang value natin ng internal energy ay 2,950. 2,950. So, dito siya papasok. 2,875 and 2,957.9. Ito yung T2 and ito yung T1. 400 and 350. The T average minus T1 all over T2 minus T1 is equals to H average, or U average pala, internal energy, U average minus U1 all over U2 minus U1. And then, shift solve or algebra, makuha natin ng 395.2 degrees Celsius. Okay, ang X natin ay NA or not applicable. Bakit hindi siya applicable? Dahil at superheated vapor, hindi siya walang ratio ng vapor and liquid. It is superheated vapor, so hindi kailangan ang quality. It has no meaning for superheated vapor. Yung quality natin na ginagamit lang natin sa liquid vapor mixture. Okay, at a given pressure, ito naman ang letter D. Okay, at ito naman letter D ay diretso na nilagay. Okay, ang saturated pressure at 75 degrees Celsius, pag tingnan natin yung system table, siguro pa nito 38.597 kilopascal. Ay, ang pressure natin dito ay 850 pascal, ay 500 kilopascal, rather. Ang value natin ay 500 kilopascal. 500 is greater than 38.597. We got the phase description of compressed liquid. And then, ang quality niya is Na. Dahil compressed liquid, there is no need to determine the liquid vapor mixture. Okay. Kaya natin nakuha yung 313.99 kilojoules per kilogram. Kung makita natin dito sa table page 7, ang compressed liquids, nag-start tayo sa values ng 5 megapascal. So at lower pressure ng 5 megapascal, hindi natin alam ang values ni ano yung property ni ng fluid at lower than 5 megapascal dahil masyado siyang maliit. So we will consider to use the compressed liquid kung we will consider to use the saturated liquid table dahil hindi available yung 0.5 megapascal. When we are using the saturated liquid table, we will always use the temperature. Temperature is 75 degrees Celsius. At 75 degrees Celsius, ano yung value ng internal energy ng fluid natin? 313.99 kilojoules per kilogram. So, doon natin nakuha yung 313.99 kilojoules per kilogram. And then lastly, para malalaman natin yung condition, ang given kanina dito ay 0, 0 yung x. Ibig sabihin, pag 0, 0 is equivalent to saturated liquid. Ang saturated liquid condition at 850 kilopascal ay 172.94. And then, ang internal energy niya at 850 kilopascal is 731 kilojoules per kilogram. So, sige, double check natin sa table. Okay, ay 850 kilopascal. Saturated water pressure table, 850 kilopascal. 850 kilopascal. Ang temperature niya ay 172.94 and ang UF is 731 kilojoules per kilogram. Ayun, same. Ayun, same lang yung nakuha yung nasa table and yung nakuha nating values.